In this session, we're going to go through a sample question to solve the sieve, to use sieve method to get a list of prime numbers up to a given limit. The purpose of this sample question is to get you familiarized with array operation, especially array element pair operation. If you think about array operation, you can handle array objects, elements one by one. And you can also, the other common request is to have some operations between array elements. So in that case, the interaction between element pairs becomes important. We already see that in the word pair example. Similarly, in the sieve method, we will use a combination of one prime mathematical number and its multiples to go through the given number range. So some explanation is here. The sieve of Eratosthenes, I guess, is an ancient algorithm for finding all prime numbers up to a given limit. The sieve method works by removing the multiples of prime numbers starting at 2. For example, we will start our list by listing everything from 2 to 100, right? If we want to get all prime numbers up to 100, so we list everything from 2 to 100. And then starting from 2, we will remove all the multiples of 2, which will bring us this one. You can see 4, 6, 8, 10. All these multiples of 2, all the even numbers are removed. Then the next step, we will go to 3 and remove all the multiples of 3, 9, 15, 21, all the way until 99. They are removed. Then we will try to do the same thing for 5, for whatever remaining, and then 7. So by doing this, we are going to be able to get the list all the way until 97, which is the largest, the prime number list lower than 100. So what we need to do is to, first of all, we definitely need to create an array of between 2 to 100, right? Then we will, this array can be a Boolean or can be an integer. We can just try to use Boolean, for example. By default, it's always true. Then starting from 2 for the array element, for each of the array elements, to 100. What we are going to do is to remove the multiples, right? Removing the multiple means we are going to go through this array again, starting from I plus 1. If the array element is I, then we are going to, if it's 2, then we start at 3. If it's 3, we start at 4 or 5. So for each array element j, let me remove it here, from I plus 1 to 100. To 100. If it's a multiple, then we remove it, right? So if j divided by percent I equals to false, equals to 0, I'm sorry, we will set array element equals to false. It's not a prime number, right? Of course, so by doing this, what we also doing is like number 4, we're also going to go through this everything divided by 4, but it's not necessarily, we don't necessarily need to do this division for everything that is already marked as false. So here we can also add if if array element equals to false, which means it's not a prime number. Actually, we should say equals to true, which means it is a prime number. Then we will do this calculation. If it's not a prime number, then we don't need to do this. We just skip, right? And then the other requirement is to print out this. So we are going to, for each array element, let's say 1 to 100, because we want to make it look better. So it should start at 1. Oops. If array element is true, then we shall print number. Otherwise, print a space, empty space, right? Now, you can also see that we asked you to print every 10 times. So here, we will say, if array, if I percent 10 equals to 0, which means we already reached this part, right? This part, or this part, or this part. Then we will print line. So these are the, so what we are doing here is just for each element, we just go through. If it's true, if it's a prime number, we will do all C, and then we print them out, right? Okay, so let's start by creating a class. Assignment 10 sieve method. So we will have a public static void main string array args. And we will print this here. Now let's add Java doc. And looks like the lines are too long, so let's make it more readable. And now we have this all prime number. Okay, so we have the Java doc formatted, and we are going to implement. First of all, we need to create a integer is prime. So not integer, boolean equals to is prime. What am I doing? Equals to new boolean array 100. Now, one thing to note, as we discussed before, all Boolean numbers, all arrays start at 0 and at the length -1. So Boolean 100 is actually 0 to 99. But you want to map that to 2 to 100. You can do a mapping. So every time there is an I subscript, you will -2, which means the 0 will be corresponding to 2. And the 98 will correspond, 98 index 98 will corresponding to 100. Or you can just starting with a 2, subscript 2, and all the way to subscript 100 by adding one element in the end. Now, because we will never touch 0 and 1, the first two elements are wasted. But comparing to readability, improve the readability, that may work too. So either way is fine. And you will see both at work. Usually for regular algebra calculations, we tend to use 0. But for natural number processing, we tend to use this 100 plus 1 methodology so that you will have a direct mapping between subscript and the number. So now let's initialize this to all true. Less than 101, I++, and is prime I equal to true. So we get the list, the array of all true. Now for each of the element, we shall start at 2, and we shall have a curly brace down here. If every element is true, then we will do a if. Now this is a valid syntax if you want to write an if statement. However, a more common way is because is prime itself is a Boolean. You do not need to test whether you do not need to explicitly write the equals equal to true or equals to false here. You can just directly put the number as the Boolean expression for this if statement, right? Now let's do a for int j equals to I+1 from I+1 to j less than 101 and j++. And now we have this. This statement we can actually directly copy. Array element equals to false means is Boolean equals to false. So after this step, we have we will go through everything, each and every element 2 times. Outside loop is for the prime numbers remaining, and the inside is to test whether inside is prime or not. So now we will do the print out. J will start from 1, j equals 0. Actually here, I think one thing we can do is we can manually set is prime 0 to false, 0 and 1 to false. Not necessary, but I just do that because I feel this looks more natural. So if array, we will do this again. If is prime, here we will have system dot out dot print a space plus I plus j, and here it should be j. And else, we will do a print we'll print space. This time, let's just print 3 spaces, 1, 2, 3. And then, if I% 10 equals to 0, If this is the 10th element, then we will do a print line. So I'm going to copy this over. Okay, so this finishes our array matrix printout. Let's run it. Oops, I think, oh, I forgot. Is if I% equals to 0, then we also need to I think there is an issue. It's here. I think we need to, each time, we need to print out. I think I found the issue because I was putting an I here, but here, on the false should only be set when j divided by I equals to 0, which means j is a prime number. So here, that's what we are testing. Okay, now, and also let's add system print just to make sure we can see that we can separate each pass. Pass plus I. And also here it should be j%10. Whenever j is 10, then we can print. Okay, now let's run. So pass 97, let's go all the way up. Pass 2, removing all the 2's, multiples of 2, all the even number. 3, removing 9 and 15 and 21, etc. 27. Then pass 5 because there's no 4. Remember, we skipped 4. 5. So all the 35, 55, 65 are gone, and 7, 49 is gone. 11, I think 33 or 55, 77 is already removed. So 13, 17, very quickly, we all the way go to the end, which is the last pass, and this is the collection of all the prime number under 100. So you can see how it works when you need to operate on relationships between elements in an array. Do a nested loop. Nested loop, outside that nested loop will go through each and every element. Then inside the loop, will go through another time of the element, which will make a cross-reference between any combination of two array elements. That's how you handle operations between array elements. And of course, you can think if we need to do a combination of 3 array elements, you will need to have 3 levels of nested loop and so on and so forth.